Hello, this is Saxon Advanced Math, Lesson 103, and we're going to begin with a little exercises with logarithms, which we will then use for a specific purpose at the end of this lesson. But to begin with, let's just review. Remember our log rules that we've already written down several times. That if I'm taking the logarithm of a product, that being mn, I can add the log of each factor of that product. If I'm taking the log of a quotient, I can subtract the log of the numerator minus the log of the denominator. If I'm taking the log of a value raised to a power, remember, the log is simply the exponent, so that's the same thing as that power times the log of the value itself. So we've been breaking things apart, and in this lesson, we're going to do a little more exercising with breaking things apart, but also with putting things back together. So this first example says to write this as they have broken this down and they want you to write it as a single logarithm. Put it back into its single logarithm form. And you're going to do it by using these rules. Remember, they're interchangeable, reversible. So if I have this, I can write it like this. If I have this, I can write it like this. Either way. So I'm going to start with that number 3 right there, because this 3 to the front, this is a 3 times an exponent, because remember, a logarithm is an exponent. So I can take that 3 and make him a power. So I've got the natural log of x squared minus 1 raised to the 3rd power. It's the same thing as. And I'm going to do it with the second one. The natural log of y squared, that 2 becomes the power of y. The third one, same thing, natural log of x plus 1 to the 4th power, and then natural log of y squared plus y to the 2/3 power. So all 4 of those examples right there, I applied this rule number 3. Now, if I am subtracting 2 logarithms, it's the same thing as taking the logarithm of their quotient. So I'm going to do that here. So this is the natural log of x squared minus 1 to the 3rd power divided by y squared. I could go ahead and write the rest of it out, but we're going to go ahead and keep working. So again, I'm subtracting. So that means I've got a x plus 1 to the 4th power on the bottom here. And then I'm adding, so that's going to be multiplying by plus y to the 2/3 power. So we've applied rule 1 and 2 to that and wrote it as a single logarithm. You'll notice in your book that they did a little rearranging of that. You can look in your book and see how they reduced that. I want you to see what happens with the 3 and the 2 and the 4 and the 2/3, and then what happens with the minuses and the pluses. And then the rearranging of this, I'm not as worried about. Number 2, you'll see that they gave you one in this form, and they want you to break it down into a linear form, is what it refers to as. So I think you can do that. I'm going to go to the part B of this lesson, where we're going to be using our logarithms in chemistry. when a liquid, the way you measure the pH level of a liquid, remember the measurement can be between 0 and 14. It is the, how much hydrogen, I believe. Hydrogen, yes. We will find the pH, which gives us the concentration of hydrogen atoms in moles per liter. So let's look at example 1. Find the pH of a liquid if H is 4.03 times 10 to the negative 6 per liter. So we're going to take, well, let me give you these two forms, the exponential form and the logarithm form of the pH. They're in your book right there. Let me put them up here so we know what we're talking about. 10 to the negative pH is equal to H plus, that's the exponential form, so pH is equal to, I think I put that name, yep, is equal to the negative of the logarithm of H. And in this particular example, our H is 4.03 times 10 to the negative 6. H is equal to 4.03 times 10 to the negative 6. So we want to know what that is in terms of our pH. So we're going to take this log form right here, substitute this in, and then solve. So pH is equal to the opposite of the log of 4.03 times 10 to the negative 6, which means, remember those log rules, is the opposite of the log of 4.03 plus the log of 10 to the negative 6. And this one right here, I know just by looking at it, because it says what exponent do I raise 10 by to get 10 to the negative 6, so that's going to be a negative 6. So I'm going to add it to, I got to do my calculator to get 4.03. 4.03 log. Yep. I get 0.605, we'll say. And we're going to take the opposite of that. Yep. Put that right there. We're going to take the opposite of that. So we're going to have negative, the opposite of minus 6. Negative 5.395. That's going to be 5.395 is the pH level. You could round it to 5.4. The next example, example 4, says find the concentration of hydrogen ions if the pH of the water liquid is 7.05. So it's given us the pH, we're given the pH, and we need to find out what the hydrogen concentration is. So the pH is 7.05. So 10 to the negative 7.05 power is going to be our H count. So I'm going to take negative 7.05, take the opposite of that, raise 10 to that power. Oh, yep, and I'm going to get 8.9 times 10 to the, and I'm going to have to count this, 1, 2, 3, 4, 5, 6, 7, 8, yep, to the negative 8 power. So this is going to come in handy in your chemistry class, so you might want to pay attention here. Miss Betsy would be proud of you. Remember your two forms, your exponential form and your log form, and then it's simply using your log rules. All right, thank you very much.